Let W be a subspace of V of F. V of F is a vector space. Then the set of all cosets, then the set of all cosets of W in V is denoted by V by W. Look at the statement, you look at this definition. W is a subspace of a vector space V of F. You know cosets. In group theory, you have learnt cosets, right coset, left coset. There are two types of cosets. V by W is a set consisting of all cosets of W in V anamata. ఇందులో అన్ని cosets ఉంటాయి. Say for example, W plus alpha. Alpha belongs to V. In group theory, you might have learnt AH is a left coset. AH is a left coset, A belongs to G anamata. This A belongs to G. G is a group. H is a subgroup. So here subgroup is subspace. Group is a vector space. There is a comparison matter. AH is a left coset or A plus H is a left coset with respect to addition. This is a left coset with respect to multiplication. Okay, na? Two types of. So it is a right coset. Right cosets and left cosets kuda anne untayi. So V by W is a set consisting of all cosets. Cosets anamata. Okay, this is called quotient set antaru. Emantarra quotient, endukante fraction undi kabatti fraction unte quotient antaru anamata. This is called a quotient set. Quotient set. Write this definition. Next one, this quotient set will form a vector space with respect to cosets addition and scalar multiplication. So before that, you write one more definition. Addition of cosets. Addition of cosets. How cosets are added? If you take two cosets, W plus alpha, W plus beta. These are the two right cosets. How these two cosets are added? Okay, na? Write the definition. Let W plus alpha, comma W plus beta be any two cosets of W in V. W is a subspace, V is a vector space. Subspace has cosets anamata. These are the two cosets of W. W is a subspace of V. Then the addition of two cosets is defined as W plus alpha plus W plus beta equal to W plus alpha plus beta. So this is the way how addition is defined. Okay? W plus alpha plus W plus beta equal to W plus alpha plus beta. Cosets multiplication. Let us see the cosets multiplication. If you take two cosets W plus alpha and W plus beta, their multiplication is defined as W plus alpha beta. Alpha is multiplied by beta. So this is called cosets multiplication. Next, there is a scalar multiplication. Scalar multiplication. What is scalar multiplication? So a coset is multiplied by a scalar. A coset is multiplied by a scalar. Scalar is a number. Okay, scalar multiplication. Let K be a scalar, and W plus alpha be a coset of W in V. W plus alpha is a coset, K is a scalar. Scalar is a number. Then this is a K into W plus alpha is equal to W plus K alpha. This is called scalar multiplication. Okay, na? Write a note, small note. The set V by W forms a vector space. It forms a vector space with respect to quotients addition and scalar multiplication. With respect to quotients addition and scalar multiplication. So, V by W is a vector space. This vector space is called quotient space. Okay, na? Though it is a vector space, it is called quotient space. This is called quotient space. Quotient space. Okay, these are the definitions must learn before we write a theorem. Very important theorem is there. Write the theorem. Dimension of quotient space is very important theorem. I will explain this. Dimension of quotient space. Quotient space. It's very important theorem. This is asked many times in the examination. First you write the statement. Statement is, let W be a subspace. W be a subspace of a finite dimensional vector space, finite dimensional vector space V of F. W is a subspace of a finite dimensional vector space V of F. Then dimension of V by W equal to dimension of V minus dimension of W. So this is the statement. You first figure out what is given, what is to be done. First let us understand what is given here, what is to be proved. So here we are given a finite dimensional vector space. What is V? V is a finite dimensional vector space. You know what is finite dimensional. A finite dimensional vector space will have a finite basis. That is the first statement given. There is another statement, another definition. If V is finite dimensional, there exists a finite set S such that L of S equal to V. Okay. Since V is finite dimensional, every subspace of finite dimensional vector space is also finite dimensional. W anedi, what is W? W is a subspace of V. V is finite dimensional. Therefore, W is also finite dimensional. So, what is to be proved here? Dimension of V by W equal to dimension of V minus dimension of W. So, on right side, RH in RHS there are two terms element, dimension of V, dimension of W element. So first let us find the value of RHS. That is one part. Finding LHS is second part. So I will divide this theorem into two. I will prove it in two parts element. In first part let us find the value of RHS. Okay. Since V is finite dimensional vector space, W is also if V is finite dimensional, its subspace is also finite dimensional. W is also finite dimensional. Understand? But by the definition of finite dimensional vector space, what do you say? Every finite dimensional vector space will have a finite basis. So then W will have a finite basis అన్నమాట. W కి ఏముంటుంది? Finite basis ఉంటుంది. Finite basis అంటే it has a basis in which there are finite number of elements. Understand? So W must have a finite basis అన్నమాట. Let S equal to, let us take a set. Let us consider a set. S is a set consisting of all alpha 1, alpha 2 and so on, alpha m. It has how many vectors? M vectors are there. The coordinality of S is m అనమాట. M is finite. ఇన్ని అని చెప్పడం ఫైనైట్ అని చెప్తారు అనమాట. ఇన్ని అని చెప్పలేకపోతే దట్ ఈస్ ఇన్ఫైనైట్. సెట్ ఆఫ్ న్యాచురల్ నెంబర్స్ ఆర్ ఇన్ఫైనైట్. Because we can't say there are how many natural numbers అనమాట. But it is a set consisting of m vectors. That means it is finite. Let it be the basis of W. W కి బేసిస్ అనుకున్నాం దీన్ని, ఎందుకంటే W is finite dimensional కాబట్టి that has a basis. Let S be the basis of W అనమాట. Let S equal to be a basis of W. Basis of W. So that is the dimension of W. What is the dimension of W? Dimension of W equal to number of elements of any basis of W అనమాట. W యొక్క ఏదైనా ఒక బేసిస్లో ఎలిమెంట్స్, ఆ Wకి S బేసిస్. S has how many elements? M. Therefore dimension of W equal to M అనమాట. Understand? Okay. So on right side one term is found అనమాట. Dimension of W is found. So next let us find dimension of V అనమాట. Clearly S is non-empty. S is non-empty. And W is a subspace of V means W is a subset of V. W అనేది V కి ఏమవుతుంది? Subspace. Subspace is a subset. Clearly W is a subset of V. It is clear అనమాట. S is a basis of W means a basis is a subset of its subspace అనమాట. S అనేది W కి ఏమవుతుంది? Basis. Basis అంటే that is a subset first. Also S is a subset of W. S is a subset of W. W is a subset of V. That means S is a subset of V అనమాట. S V కి subset అవుతుంది. S is non-empty. S is non-empty. S is non-empty and is a subset of V. S is non-empty and a subset of V. What is S? S is a basis. Basis means it is a linearly independent set. Basis is a linearly independent set. So S is linearly independent. S is linearly independent అనమాట. So if you look at these two, if you look at this sentence, what can we remind? It reminds us the basis extension theorem అనమాట. Basis extension theorem. In basis extension theorem ఏంటి? If S is a non-empty subset of V, if S is a non-empty subset of V, S is linearly independent, then ఇఫ్తో ఉన్నాయన్నమాట. ఇఫ్తో ఉన్నాయి ఈ రెండు. నాన్-ఎంప్టీ సబ్సెట్ ఆఫ్ V అవ్వాలి అండ్ S is linearly independent అయితే దెన్తో ఉన్నది ఏంటి? దెన్తో రెండు ఉంటాయి అనమాట. దెన్ S is either a basis of V. S అనేది Vకి బేసిస్ అవ్వాలి. లేకపోతే S can be extended to form a basis of V. That is basis extension theorem. So here S is non-empty and which is a subset of V. ఇది ఒకటి జరిగింది. This holds. And second one is S is linearly independent. S is linearly independent. So by basis extension theorem we can say that S is either S is either a basis of V. S అనేది V కి బేసిస్ అవుతుందా? S is a basis of V. Is it right? No. S V కి కాదు, W కి బేసిస్. S is a basis of W. That is okay. But S is not a basis of V. అంటే దెన్తో ఉన్న రెండిట్లో 1 is does not hold and 1 does not hold. S is a basis of V జరగట్లేదు. సెకండ్ వన్ జరుగుతుంది అనమాట. ఆర్ ఎస్ కెన్ బి ఎక్స్టెండెడ్ టు ఫార్మ్ ఏ బేసిస్ ఆఫ్ వి అనమాట. సో బై బేసిస్ ఎక్స్టెన్షన్ థియరం, ఎస్ ఈజ్ ఎయిదర్ ఏ బేసిస్ ఆఫ్ వి దట్ డస్ నాట్ హోల్డ్ అనమాట, అది జరగట్లేదు. దెన్ విచ్ వన్ హోల్డ్స్? ఎస్ కెన్ బి ఎక్స్టెండెడ్ to form a basis of V. S can be extended to form a basis of V. So if you extend S, extending S means adding some elements to S. S ki konni elements ni add cheskondi. Already S has m elements, m vector anamata. You add a few elements or few vectors to S. Let us add some betas anamata. That extended basis is taken as P, like P equal to alpha 1, alpha 2 and so on, alpha m. These are already existing vectors. You add some betas, beta 1, beta 2 and so on, beta L. So L vectors are added to S. A new set is formed that is taken as P. Okay, P is a basis of V anamata. It is an extended basis anamata. P equal to this is a basis of V. And V has a basis in which there are how many elements? L plus m or m plus L elements are there. Therefore, what is the dimension of V? Therefore, dimension of V equal to m plus L. So dimension of W and dimension of V are found anamata. Okay, what is the value of RHS? Take RHS. RHS equal to dimension of V minus dimension of W. This equal to dimension of V equal to what? M plus L. Then dimension of W is M. You can get m get cancelled, the remaining is L anamata. So RHS equal to L. So if you can find LHS equal to L, then theorem will be okay anamata. Okay na? So LHS kuda L ani cheppali man. What is on LHS? What is in LHS? Dimension of V by W anamata. If dimension of V by W equal to L, then theorem is proved anamata. So I will explain this part in the next class. Thank you.